At this point, I wanted to review your properties of logarithms and exponentials. I'll let you do that on your own. Okay. Will, there was a question.
So yes, will I get a copy of that, or would I have to print it?
Yeah, you'll have to print it. Yeah, but for today, maybe just copy it down and then print out the notes and copy it over. Yeah. All right, folks. There's a sequence for doing this. I'm sorry. I'm going to do it this way. I'm going to start at 6 because that's the one I remember first, and then I'll do the sequence that way. You can do the sequence many different ways, but I want to do it this way. Okay? So I want to find the derivative of the natural log of x. Okay. Well, I could write y equals the natural log of x. This is a what type of function using our vocabulary from the last section? This is an explicit function, right? But the problem is and this is a really powerful tool, the problem is I don't know how to take the derivative of this explicit function. I haven't learned. So let's go ahead and rewrite this explicit function as an implicit function. I can rewrite this as e to the y equals x. True? So I gave the corresponding exponential equation. Do I know how to take the derivative of e to an expression? Yes. So this is helpful. Okay. So now I'm going to implicitly differentiate. That's why we had to cover that last section first. Now I'm going to implicitly differentiate both sides. What is the derivative of e to an expression? E to that expression times that expression's derivative. Good? On the right-hand side, the derivative of x with respect to x is just 1. Okay? What are we trying to find? We're trying to find the derivative of y, so let's go ahead and solve for y prime. So solving for y prime, we get y prime is equal to 1 over e to the y. That's nice, but our original function was a function of x. So now what I'd like to do is back substitute what y was taking the place of. Well, what does y equal?
Natural log of x.
So we can replace this with the natural log of x. We replaced the y here with the natural log of x. Does everyone see that substitution? Again, because we started off with the equation, y is equal to the natural log of x. So if I see a y, I can replace it with the natural log of x. Okay? This property we didn't get a chance to review. That was in that review section up at the top. What is e to the natural log of an expression?
The expression.
It's just the expression. Everyone hear that? What Freddie said? These two operations, it's hard to see it, but these two operations, e and natural log, sort of cancel one another out. Okay? So we're just left with 1 over x. This is just like if I asked you to take the cube root of x cubed. What do you get? You get x. If I ask you to take e to the natural log of x, what do you get? You get x. By the way, if I ask you to take the natural log of e to the x, what do you get? You get x. Because those are inverse operations of each other. Okay, there it is. The derivative. Let's summarize. Actually, let's summarize that this way. The derivative of the natural log of x is what? It's 1 over x. Everyone hates the natural log. It's a poor function. No student has ever said, "I love this function." It's got one of the prettiest derivatives. It's ugly on the outside, pretty on the inside, right? Its derivative is 1 over x. That's very elegant compared to what you thought it might be. Okay? By the way, I guess, calculus is a visual subject. If you've got room, here's a tiny little graph. Here's the graph of the natural log of x. Okay. Let's look at its derivatives. The derivatives would start out very, very, very positive, right? And then what would they do? They're leveling off. Okay? what does the graph of 1 over x look like? Well, it has two parts, but I'm only going to look at this part right here, the 1 over x part where x is positive. Okay, it does have a second part, but that doesn't apply to the natural log because the natural log only has domain values that are positive. Okay. Do you see what's happening? Where the natural log of x has a very steep tangent line, 1 over x is very, very positive. Okay. And as we move along, the tangent lines to x, to the natural log of x, they start to level off. As we move along, the derivative starts to approach 0. Okay? So always try to keep that visual perspective going. I can't always put up a graph, but it's helpful. I think now it's clear. The derivative of the natural log of x looks like it should be some sort of reciprocal function. Specifically, it comes out to be nicely the 1 over x function. All right. So sorry to do that a little out of order. I'm sure I could do it this way, but I just don't trust myself to do it on the spot. Okay? So now let's go ahead and find the derivative of a to the x. So if I say y is equal to a to the x, I'd like to take its derivative. But I don't know how to take the derivative of a to the x. There's a couple of things I could do. What I'd like to do is take the natural log of both sides. Okay? This is important, folks. Where is x? It's the power of an exponent. I don't know how to take that derivative unless the base was e. That would be the only case I'd know how to do it at this point. Okay. So I've taken the natural log of both sides. Why? Well, I didn't really want to take it on the left-hand side, but I had to. On the right-hand side, what can I do now? I could make it into an e. I'm not going to. That's how I would do it if I remembered. Okay? But I decided to do it this other way. What can I do with that x, though, that's inside the logarithm?
Bring it up forward.
Yeah, remember that I could pull the x out as a factor. Okay, folks, I see sort of three parts to this equation. I see the expression on the left-hand side and these two factors on the right-hand side. Do you see the three parts? How many constants are there? The natural log of y, that's not a constant. That's a function. X, that's not a constant. What's the natural log of a? A is just some number, and when you take the natural log of a number, you get another number. So folks, I need you to practice seeing that this is a constant. I know that looks hard. That's hard for you to see it because we haven't. I mean, normally a constant looks like 12 or 17, but the natural log of a is also a constant. Okay, so that tells us that the natural log of y is equal to the natural log of a times x. I've just reordered it. Now what should we do? We could get an e, but I'd like to take the derivative of both sides through implicit differentiation. Okay? So if we take the derivative of both sides through implicit differentiation, okay, then we get what? What's the derivative of 1 over y? Excuse me. What's the derivative of the natural log of y?
1 over y.
Very good. 1 over y.
Or dy dx.
Y prime, right? Or dy dx, exactly. Okay. Equals, what's the derivative of a constant times x?
Constant.
It's just that constant, right? Right? If I said we had y equals 3x, what is the derivative of the constant times x? It's just the constant, right? So don't let the disguise fool you. It's just a constant. Okay. So this gives us that y prime is equal to the natural log of a times y, or y prime is equal to the natural log of a. What was y?
A to the x.
A to the x. So what is the derivative of any exponential function? It is the natural log of the base of that function times the exponential function. Okay? I apologize, I didn't give you room to maybe jot this down. Maybe you have room. What if I gave you y is equal to e to the x? Does this fit the mold? Can I use that derivative rule on it? So we said if y equals a to the x, its derivative is the natural log of the base times the original exponential. Does that hold for the e to the x? Oh boy, let's look. If we take the derivative, it'll be the natural log of e times e to the x, following this rule, not our usual rule. But what is the natural log of e? And so all is right with the world, right? Regardless of how you think of taking the derivative as a general exponential or the exponential, we get the derivative of e to the x is e to the x. Okay. Boy, how do you tell a college algebra student why e to the x is why e is important? Down the road. Trust me. All right, let's do some concrete examples. If f of x is equal to 8 to the x, then df dx is equal to the derivative of 8 to the x. What is the derivative of, of this exponential function?
Natural log of a times a to the x.
There it is. Okay, folks, I will test you on this one on the next exam, because I have to. We probably won't use it very much in between now and then. This is easy to take the derivative of, but it's also easy to forget. Okay? So do know that you will get one of these on your next exam. Okay? All right. Let's do a little more complicated one. Why is this one harder?
Chain rule.
You're going to use the chain rule, right? So we get y prime is equal to the natural log of 2 times 2 to the 3 plus sine x. But then since the expression inside of there was more complicated than the x that we used when we derived the rule, right? When we derived the rule, I put an x there. Here I'm putting an expression more complicated than just an x, so I can compensate for that with the chain rule. So this would be times 0 plus the cosine of x. We feeling more comfortable with the chain rule? Takes a long time. Yeah, I wish I could teach you the chain rule, say go home and think about it for 3 weeks, then we'll take a test. Such is life. Okay. We can clean this up a little bit. We get y prime is equal to natural log of 2 times the cosine of x times 2, 3 sine of x. There's other ways to write it. Oops, 3 plus sine x. There's other ways to write it. But normally, it is customary to put the constant out in front. All right, next one.
Can I just comment?
Oh, yeah, of course. Yep. Slow me down. Folks, whenever I'm teaching, there's a little voice in the back of my head just saying, go faster, you gotta get through it all. All right. So let's try this one. Let's find the derivative of any old log-based function. So I'd like to find the derivative of y, where y is equal to the log base a of x. Here I've got it, again, the same technique. I've got an explicit function, but I don't know how to take the derivative of that explicit function. So the trick is to write it as its implicit function, and we get that a to the y is equal to x. Now what are we going to do?
Log both sides.
I don't want to take the log both sides because I'd be back to this side, back to what I started with, right? What's that, Angel? Take the derivative implicitly of both sides, right? We've just written this as an implicit function. Now let's implicitly take the derivative. So that gives us, well, I'll do the right-hand side. What does that give us on the left?
The natural log of A times A to the log.
The natural log of A times A to the expression what's that, Sarah?
White.
Times the derivative of that expression, right? By the chain rule. How we doing, folks? Now let's solve this for y prime. We get y prime is equal to 1 funny looking one. Y prime is equal to 1 divided by the natural log of A times A to the y. Am I done? Who said that? Yeah, Justin said we got to substitute what y is taking the place of currently. So let's do so. We get y prime is equal to 1 over the natural log of A times A to the log base A of y. Oh, excuse me, log base A of what? X. So we get y prime is equal to 1 over the natural log of A times what is A to the log base A of X? It's a little bit hard to see. It's just X. To cancel each other out. Log base A and A to the cancel one another out. Okay? So what is the derivative of log base A? It's 1 over the natural log of the base times X. Okay? Folks, one more time, everything we did with the natural log, it still fits into it. If I say y is equal to the natural log of x, then its derivative will be 1 over the natural log of the base. Well, what's the base of the natural log function? E times x. But that just gives me 1 over 1 times x, or 1 over x. You wouldn't I mean, if I said y is equal to the natural log of x, you would use the other rule that we first developed. But see that these rules are consistent with the logarithm and the exponential. All right. So now you get the uncomfortable job of incorporating these two new derivatives in with everything else you know. Right? So let's see what we can do with that. See if I can help you a little. F prime of x is equal to 1 over x plus 1 over the natural log of 2 times x plus 1 over what's the base of that last logarithm? No? It's base 10. And all of the time that any mathematician has ever saved by not writing base 10 there is automatically lost by all the time the mathematician has to explain that there's a base 10 there. Right? So just as a reminder, you would expect to write the log base 10 of x, but instead we write the log of x. It's a time saver until you have to explain it every time you do it. So this is going to be what? 1 over the natural log of what? 10x. Questions on that? Okay, let's take it up a notch. What is f prime of x here? The derivative of the log base 10 of something is... These rules don't quite roll off the tongue. 1 over the natural log of 10 times that expression. But now what do I have to do? I have to multiply that by the cosine of x because it's the derivative of that expression. Let me scoot that over.
So would you need to bring the cosine x out from underneath?
Well, yes, indeed. Yeah. Because what does the chain rule say? It says if you have y equals f of g of x, then y prime is equal to f prime of g of x times g prime of x. And I know you know that, but the times there is to the entire expression, not the denominator of the entire expression. Right? Great. All right. We'll do C and then we'll call it good. Folks, I'd like to make a minor adjustment to this. 1 second. I would like you to change this to a 5 right here, if you would. Just so we actually have to do a problem. Okay. Folks, so I said before, you need to be familiar with your properties of logarithms, your properties of exponentials. Okay? I wish we had time to spend 3 weeks of review for this class. We just don't. So, this problem, I think, reviews most of the properties of logarithms that you need. So let's take a look. Rather than taking the derivative, I'd like to first rewrite the function. So, what is the natural log of e to the 7x?
7.
It's just 7x, right? Because the natural log and the e, those cancel one another out. So we just get 7x. Okay? So then what would this be? This would be minus what?
X.
Minus x. Okay? Now, what can I do with multiplication outside of a logarithm? If I choose, what can I do with that constant being, or that expression being multiplied to the logarithm? I can bring it in as an exponent. So this will give me plus the natural log of 1 over x all to the 5th power. Everyone see what I did there? I pulled the power in, I pulled the constant, the multiple inside the logarithm as a power. Plus, I'll go ahead and leave this guy alone. And let me do the same move over here. Okay? So I'd like to bring this 2 inside. So it's going to come in as the square root of x squared inside the logarithm.
Which is just x, right?
Yes, yes it is. There's a slight argument there though, right?
Plus or minus.
Well, normally you'd have to put an absolute value on it. But if I'm already taking the logarithm, it's already got to be a positive expression. Nope. Where? Here. So because here I'm taking the same, it's the same x, and it has to be positive here, then it would also have to be positive there. So there's a tiny little argument that says before you can not have to put the absolute value. Okay, so this gives us 6x plus the natural log of 1 over x to the 5th plus the natural log of x to the 7th minus the natural log of x. Okay. More properties of logarithms, folks. I have an addition of 2 logarithms of the same base. What can I do? I can combine them as a single logarithm if I do what? Uh-oh. Yeah, I'm glad we're doing this problem. If I multiply their arguments. Okay? So, I didn't review this property. Looks like I have to. If I take the log base a of m plus the log base a of n, that's equal to the log base a of m times n. Okay? Folks, I remember that as addition. Where? Where is the addition? It is outside the two logarithms. Addition outside is equal to multiplication. Where is the multiplication? Multiplication inside. I've had students just say multiplication goes with addition, or addition goes with multiplication, and they make mistakes. So remember that inside and outside part to it as well. Okay? So now we've reviewed that property. Let's look back here. What did I have? I've got addition outside two logarithms, so I can write that as multiplication inside those two logarithms. Okay. This gives me 6x plus the natural log of x squared minus the natural log of x. But there's another property. I'm not going to write this one, but it's the same property but with subtraction. I've got subtraction between two logarithms of the same base with no numbers in front of them of the same base. So I can rewrite that as division inside. What's that? And so everything cleans. So yeah, it was worth taking the time, I think, to clean up this function. Because now we're ready to take this function's derivative. We get f prime of x is equal to 6 plus 1 over x.